So today our topic is about the common emitter transistor as a current signal amplifier. Last time we have discussed the common base transistor. Now our topic is about the common emitter transistor. In common emitter, as we know that in common emitter transistor, this may be like this. If the current is coming out from the emitter, then this will be a NPN. Okay, this will be blue will be NPN. NPN. If there is a if arrow is inside, then this will be a PNP. So that will be a difference. Okay, got it? So okay, this will be a input and this will be a output. Okay, so here will be a two junction. This junction will be yes. This junction will be yes. What is this junction? Beta, please. This is a base, this is emitter, this is collector, and this is emitter. So the this is actually the common emitter transistor. Okay, you may say that this is like base, emitter, and collector. Okay. Okay. Base emitter junction. Base emitter junction must be as I have already discussed. Base emitter junction will be always for active transistor. The base emitter transistor must be a forward bias. Okay. For active mode, one minute. For what I have discussed, that for active mode, the collector base will be a reverse bias, and base emitter will be a forward bias. So you may say that okay, base will be a positive, okay, so it depend upon that if it is a NPN और a PNP. ठीक है, तो बेस आपका जो जंक्शन है ये फॉरवर्ड बाइस होना चाहिए. तो बेस को अगर आपके पास if it is if this is a NPN, okay, if I say that this is a NPN, okay, then plus must be connected with the plus, and emitter must be a negative for forward bias, okay, and similarly collector which is a negative, that must be a plus, and base must be connected on negative. Okay, so this is two circuits. This for NPN, and for PNP, if this is a P, if this is a PNP, then this will be a minus, this will be plus, and this will be a minus, this will be a plus. So this will be a reversed. Okay, I have already explained it. What is the main reason of this? Okay. Okay, to understand the functions of this, input क्या होगी? What is will be input? Input current will be, yes, input current is IB, because in the last lecture input current was IE, emitter current was the input, but for this circuit input current will be a IB, base current, okay, because base will be decided, okay, and input voltage, what will be the input voltage? Yes, this is base meter, okay, so okay, blue symbol is representing the NPN, and black symbols are representing the PNP. For NPN, positive, base will be a positive, and emitter will be a negative. For PNP, base will be a negative and emitter will be a positive. So that's the main reason. Okay, I may say that in this way. I also write for I in will be IB, okay, and V in will be, yes, what is the input voltage? Input voltage is between base and emitter. Base is base and emitter. For black, for PNP, that will be EB. Yes, yes, you are right. Okay, what will be the about output? Yes, yes, I out will be, yes, yes, I out is IC, and V out will be, yes, V out is CE, CE or EC. So that is the difference. Okay, as we have already discussed many and many time, emitter current will be always equal to, yes, that will be divided to IC plus IB. That is a common equation for all transistors, and the other equation was IC will be equal to, yes, IE, okay, alpha IE plus ICBO, my common base output. Okay, that is the equation, exactly the same equation which is used in the common base emitter. That's why this is a reverse current for common base. Okay, and O mean that was a leakage current, open. Okay, reverse current. Okay, so this will be two equations. This will be a 1 and this will be a 2. Okay, if I put this value in this equation, because this current is actually the common base current, and it is representing the common base transistor current, but I have to convert it into the common emitter current. Okay, so if I put this in this equation, the IC will become, yes, alpha I is equal to IC plus IB plus ICBO. Okay, and this may be right in this way: alpha IC plus alpha IB plus ICBO, or I may say that 1 minus alpha is equal to IC alpha IB plus ICBO. So this will be our result. Okay, so this will be a equation. Got it? And I think I may erase this. ओके कोई बात नहीं, कोई मसला। Okay, so from here IC will be equal to, yes, because we have to calculate the IC will be equal to alpha divided by 1 minus alpha IB plus ICBO. Okay, I have divided it into this side. Okay, I have divided it into sorry, this yes, 1 minus alpha ICBO. Yes, you are right. Okay, now it's okay. Laterally I will explain. This will be equal to beta. Okay, this will be defined as a beta. Why this is defined? Second equation. G. CBO. G. Yes. So alpha 1 minus beta, alpha, 1 minute please, wait. 1 minus alpha, this will be equal to beta, yes? Yes? If I add beta plus 1, that will be alpha into alpha, 1 minus alpha plus 1 okay, so beta will be equal to 1 minus alpha. If I say that this is A, this is B equation, okay, and if I say that this is X equation, putting alpha beta equal to alpha into 1 minus alpha. This was a 1, this was a and B is beta plus 1 is equal to 1 minus alpha, and this is equation B. Okay, put in equation X this, then this implies that IC will become, yes, beta IB plus beta plus 1 ICBO. This is a Y equation. Okay, this is your equation. Okay, so collector current will be depend upon the beta value. Okay, and beta is alpha value is from 0.95 to 0.98. I have already explained it in the previous. Okay, so beta value will be, this implies that beta value will be changed from beta which is equal to alpha divided by 1 divided by alpha. If I say that 0.95 divided by 1 minus 0.95, so what will be become, this will be equal to, yes, what will be the value?
0.95 or 0.05 ये 15 के तकरीबन.
Okay, so this value is 19, and for 0.98 beta will be 0.98, 1 minus 0.98, this will be equal to 0.98, 0.02, and that will be equal to, yes, this will be equal to round about this will be a 49. So beta value will be changed from 19 to, if alpha value is 95, then beta value will be 19. If alpha value is 0.98 for alpha equal to, then that will be a 49. So so even there will be a little bit change in alpha value, there will be a large change in a beta value. Okay, got it? Beta. Okay, this will be your result. Okay, if you have if the value is 0.95, then that beta value will be 19, and the other case that will be. Now output current is a proxy. Okay, now this equation, if I say that this is as I have already explained, IC beta IB plus beta plus 1 ICBO. This why this will be equal to this, as I have already explained, in the case of common base, the current must be, collector current must be divided into base, okay, input current and leakage current, output leakage current. So this will be your result. Okay. Okay. 1 minute. Okay. Since beta is very, very, very large for alpha is very small, for alpha since beta value is a very large, I have already explained that beta value is from 19 to 49 for alpha 0.95 to 0.998. So as we know that beta value is a very large as compared to alpha, and beta value is because collector current is multiple of the because since I out जो collector current है is multiple of beta है, ठीक है, और बीटा जो है वो क्या है आपके पास very large है, तो आपके पास क्या हो रहा है IC is a very so IC is very large for I input, हाँ जी, for input is a IB small. Therefore common emitter transistor used as current amplifier because it amplify input current signal IB to amplify
दो बंदे कम हो गए, क्या मैं बैलेंस करने के लिए वापस आ सकता हूँ? आ जाओ
current IC. So IB so if your input base current is even small, common collector current will be a very large, so it will be increase the signals up, okay. And if we consider CEO is very small, then IC will be beta IB, and beta will be equal to IC over IB. Output current divided by input current for common emitter transistor, and alpha is so that is this is a common current gain for a common emitter transistor, and this is a current gain for a common base transistor. ये बाद में बात करते हैं, ठीक है, अभी ये लेक्चर पूरा कर so and since I common emitter leakage current is equal to yes, that was equal to beta plus 1 I common base current and beta is large, so CEO is very large as compared to CBO. So for today it is enough. Okay, so this is used as a common so this is used common emitter transistor used to amplify the current signals. Okay, if you have a low current signal, then it will be amplify the it will amplify the low current signals. But common base transistor will be decrease the current, but common base transistor will be always used to amplify the voltage. Okay, if input voltage signal is low, by using the common base transistor we can amplify the voltage. Okay, so that is the difference between common base transistor and common emitter transistor. Got it? If you have any question, action working, I don't know, that is a different name may be used, but usually this is used as a amplification, current amplification. Okay, and common base transistor is used for a voltage amplification. Yes, yes, that's the difference.